So the last example we did, we went through examples of positive, negative, zero, and undefined slope. And those are four terms you have to know. You have to visually be able to recognize what's happening with each one of them as well. So if you see a graph, you should be able to, just from looking at a graph, tell me what kind of slope you're going to have: positive, negative, zero, or undefined. The value of it, you're only going to get instantly from the zero or undefined slope. Zero, of course, it's going to be zero slope, and for undefined, there is no slope. But the positive and negative, those are the ones you actually have to calculate out. But just by looking at a graph, you should be able to tell me right away what kind of slope you have. That's the first thing you should do whenever you get to a problem. Okay, what kind of slope am I going to have? Oh, this one's going to be positive. That way, when you do your calculation, if it comes out to be something not positive, you know you've made a little calculation error along the way. So that's why we have these categories, is to check ourselves before we start the problem, so then when we finish the problem, we're confident in our answer. Now, of course, there could still be a calculation error that gives us the wrong positive slope, but, we can't have a little category for everything. That's why we have the calculations. One important thing here, too, is slopes. We can also interpret them as rate of change and think of that of things like miles per hour. That's speed. That's a very common rate of change we talk about. If you are going very, very fast, it is a very, very steep positive line. If you're going very slow, it's a very shallow positive line, right? So this is fast and this is slow. If you're talking about slopes in terms of miles per hour. So just keep that in mind. There are relationships between them, and we will use that. Like in example 2. A pilot flies a plane from Columbus, Ohio to Orlando, Florida. After 0.5 hours, the plane reaches its cruising altitude and is 620 miles from Orlando. Half an hour later, the plane is 450 miles from Orlando. How far was the plane from Orlando 1.25 hours after takeoff? Okay. So let's take a look at it here. Let's break down some stuff. So we've got where we're leaving and where we're heading, right? So a half hour, it reaches its cruising altitude and is 620 miles from Orlando. So to me, 0.5 and 620 miles, that sounds like a coordinate. The time and the distance. And a half an hour later, which would be another 0.5 later, right? So it would be 0.5 plus 0.5, so another at 1 hour in the air. The plane is 450 miles from Orlando. How far was the plane? So we're not to the part yet where we get to answer like how far the plane was in between those, like in another 0.25 hours. But let's calculate its rate of change based on these two coordinates: time and distance to Orlando, right? So 450 minus 620 over 1 minus 0.5. So here it's a negative slope, it seems like, which makes sense because if you start off in Columbus, Ohio, and are heading to Florida, that should be a negative line there, but let's keep going. 450 minus 620 is going to be 50, gives me to 500. Another 100 gets me to 600, so another 20. So negative 170 over 0.5. So if I were to have a rate of change here, 170 divided by 0.5. It's the same as multiplying by 2. I don't know why I'm doing it on my calculator. It's going to be negative 340 miles for every hour that it takes off. So I did it again, where all that work is underneath the video. Wow. Okay. I'm messing up on these videos a lot. I might have to remake them. So, I just simplified them out here. I just did the subtraction. Got it. Divided it out. And I got this rate of change here. Now, an important thing about this rate of change, it's negative because the distance to Orlando is decreasing, right? It's getting closer and closer by the minute. So that's why it's a negative miles per hour. We don't really need to worry about the negative all that much because what we kind of want to do is figure out how far the plane was from Orlando 1.25 hours after takeoff. So at 0.5 hours, it was 620 miles away. So we're trying to figure out at 1.25, we're trying to figure out how many miles away it was. So we're going to do something kind of interesting here. We're going to say, we'll call that y, it doesn't really matter. We're going to be looking for that missing coordinate. And the thing is we might not know what it is right now, but we know when we plug all of these values in together, it should come out to be the same rate. So, y minus 620 over 1.25 minus 0.5 equals negative 340 over 1. And now you can see I just have a proportion that I have set up where I have to find the value y. All I did was made these two coordinates, or these two data points here, into coordinates that I could plug back into the formula. Give myself a little bit of space to work with here. And we'll continue this problem down here. Y minus 620 over 1.25 minus 0.5 is 0.75 equals negative 340. Multiply both sides by 0.75. And I get y minus 620 equals negative 255. Add 620 to both sides. If you missed it, I multiplied each side by 0.75. That canceled it out. And we get y equals 365. So the plane is 365 miles from Orlando at 1.25 hours after takeoff. And we can stop and check to see if that answer makes sense by reading the original problem. Half hour after takeoff, it was 620 miles away. Another half hour later, an hour later, it's 450 miles away. So a little bit beyond that should be even closer, and you can see 365 is a little bit closer.